All right, so section 2.4 talks about measures of variation. And it says in this section we're going to discuss ways to measure the variation or the spread of a data set, beginning with the range. So it says the range of a data set is the difference between the maximum and the minimum data entries in the set. To find the range, the data must be quantitative, so we're going to be dealing with numbers, right? The range is just the biggest number minus the smallest number, okay? The next part says, the deviation of an entry X in a population data set is the difference between the entry and the mean, remember the symbol? Mu of the data set. Okay, so the first example here says find the deviation of each starting salary for corporation B in the following example. Okay, so we have salaries. Okay, so these are salaries: 55,000, 61, 51, 68, 59, 52, 61, 63, 65, and 58. Okay, so the first thing we're going to do, let's see if we can find the average. So I'm going to take my calculator again. I'm going to turn it on. I'm going to clear it out. I'm going to go to Stat, okay, right there. And then I'm going to hit Enter so I can edit, because I'm already on Edit. And if you remember from earlier in 2.3, I had made my list, right? I don't want that list anymore. So to clear it out, I'm just going to go to where it says L1. I'm going to hit Clear. I'm going to hit Enter. So now my list is clear, okay? So when instead of me having to enter 55,000 and 61,000, if you notice, we just have the salaries here in thousands. So let's go 55 and 61 and 51, 68, 59, 52, 61, 63, 65, and 58. Okay, there's 10 people there. There we go. Okay. And now I'm going to go back to Stat, and I'm going to calculate my one variable statistics, okay? And so the first thing I want to do is I want to find my X bar, my population, or my population mean. Okay, so I know that, oops, get my pen going again. Sorry guys, sometimes my pen freezes up. There we go. Okay, mu is going to be my population mean. On my calculator, it never gives me the mu, but it will give me X bar, and it's going to be the same thing in these cases, okay? So 59.3. So right here, we're going to say 59.3. Okay, what we want to do is we want to find what we call the deviation. We're going to do this. We're going to take 55 minus 59.3, 61 minus 59.3, 51 minus 59.3, 68, 59, 52, 61, 63, 65, 58. Okay? So I'm going to take all those differences, okay? So guys, I'm going to pause so that you don't have to sit here and watch me subtract a whole bunch of numbers, okay? And then I will come and I'll write them all out in black, okay? So let me pause my video, and when you come back. Okay, so filled in my chart, right? Okay, now look at the last part. The last part has that sigma notation. Remember, sigma means to, there we go, to add. Okay, so let me get my calculator one more time, and let's do this. 4.3 negative 1.7 plus negative 8.3 plus 8.7 plus, where am I? 0.3 plus negative 7.3 plus 1.7 plus 3.7 plus 5.7 plus negative 1.3 and, okay, I made a mistake over here, guys. Oops, let me see if I can find it, okay? Let me pause, I'll be right back. Okay, so entered, I had made a mistake right here. It's supposed to be a negative, and I forgot to put it. All right, so I put all the numbers in, add them all up, and look what we get. We get 0. Okay, and it says right here, note that the sum of the deviations is always going to be 0. And it says this is not going to help if we want to attain an average of the deviation. So we wanted to figure out on average how much do each of these salaries change from the average. How would we do that? And if we add them all up, we end up with 0, right? Okay, so there's something called the population variance, and there's a formula here, okay, and I'm going to kind of explain it. So this little formula right here, guys. So this guy here is the small sigma. Okay. And because it's squared, it's going to be sigma squared equals, remember, this here is the sum of all those numbers, but now those numbers are being squared divided by the total number of n, right? Total number of entries that we have. Okay, and then we have something called the population standard deviation. All we got to do is whatever answer we get here, we take the square root of it, okay? So this next part here would mean all those numbers that we had here, negative 4.3, 1.7, all these numbers here, I would fill them in here, and then in this column, I would have to square each of those numbers, right? Okay, I don't want to do any of that. The reason I don't want to do any of that, it's going to take me a really long time, and we can do a lot of this stuff with our calculator, okay? So, there's the same thing, guys. We also have the same thing for the sample. We have a sample variance and a sample standard deviation. I'm going to explain how we're going to do some of those calculations here, okay? So we will do it with this problem right here. It says a sample of 10 college students was drawn from a large university. Their ages are 22, 17, 27, 20, 23, 19, 24, 18, 19, and 24 years. Find the range, the mean, the variance, and the standard deviation of the sample data set. Okay, so I'll tell you what I'm going to do. I'm going to come back over here. I'm going to clear this out. And I'm going to go to stat. Okay. Let's see. I'm going to go to edit. I don't want to clear this list. I'm going to come back to it in a little bit. So right here, I'm going to go to L2. Okay, and I just moved over one spot. And what I'm going to do in my L2, I'm going to enter those numbers in that we have. We have 22. Okay. We have 17. We got 27. We have 20. Okay. We got 23. We have 19. Right, 23. Yeah, 19 is the next one. Let's see, 24, 18, 19, and 24. Okay, so the first thing it wants us to do, it wants us to find the range, okay? So I don't necessarily need my calculator to find the range. What was the biggest number that we had here? It looks like the biggest number that we had was 27, okay? So number one, we're going to find our range. The way we're going to find our range is we're going to take 27 minus, what was the smallest number that we had here? It looks like the smallest number was 17, okay? So 27 minus 17, that's going to give me 10, okay? So we found the range. Number two, let's find our mean. Remember what our mean is. Mean is going to be the x bar. So I'm going to come back to my calculator, right? I'm going to go to stat. I'm going to go to calc. Let me bring my calculator this way. Okay, one variable stats. Now, I'm really dealing with the second list I created, okay? So in order to get to the second list I created, I want you to notice right above the number 1, you see L1. Right above the number, you see L2, so on and so forth. So I'm going to go hit second and L2. I want to make sure I'm dealing with that second list, okay? Enter. Okay, so here we go. Here's my X bar. It's 21.3, okay? So, and I remember the first lesson we did was like salaries. So we knew that the salary, was something like 59,000 or something like that. Okay. So 21.3 years, okay? Number 3, we're going to find the variance. Okay. All right. Because this is a sample data set, okay? Sample data set. There is something that we call the sample variance and the sample standard deviation, okay? I want you to notice the symbol for the sample standard deviation. It's the letter S, okay? So what I'm going to do here is I'm going to put number 3, which was the variation, and number 4 was the standard deviation. And because we're talking about a sample, it's going to be the sample standard, deviation. Okay. So I'm going to grab my calculator again, and I want you to look. If you see right here, do you see how it has that SX? That is my sample standard deviation. So again, I'm going to go to 3 decimal places. So 3.19, I would have to convert that 8 to a 9. So 3.199. Okay. Oops. Sorry. You need to do that? Okay. So this is going to be 3.199. Okay. Now, I'm going to come back here because I know this gets a little confusing. So remember, my sample standard deviation is S. Notice how I find the variance. I need to square it. So I'm going to come back to my calculator again, and I'm going to type in 3.199. This is my square button. I'm going to square it, and I'm coming up with 10.234. And that's going to be my variance, 10.234. And I found my sample standard deviation and my range, my mean, my variance, and my sample standard deviation, okay? So I want to come back to the problem that we were doing earlier over here, okay? Let's see if we can find the because I never finished it. Let's see if we can find the population variance and standard deviation, okay? So I'll tell you what, using the same numbers that we had here, okay, let's do this like we did earlier. Number 1, let's find the range, okay? And did we ever find the range? I don't think we did. Okay, so let's find the range. What was the highest salary we had? It looks like the highest salary was 68,000, okay? I'm just going to use 68. The lowest looks like it was 51. So the range is going to be 17,000, right? Okay, number 2. We already found the mean. We have found it earlier. The mu we said was 59.3. So remember what that means. Because this is in thousands, it means it's 59,300. Okay. Then we have something called the variance and the standard deviation, okay? So look, I'm going to pull up my calculator one more time. I'm going to clear that out. I'm going to go to Stat, go to Calc, and hit my one variable stats. I want to go to the first list that I created earlier. So I'm going to make sure I'm doing L1. Okay, here we go. I want you to notice my sigma. My sigma is going to be my standard deviation. So right here, I'm going to type in 5.197. So right here, 5.197, and actually this is really in thousands. Oops. So I want to think about this really as 5,197. And then to find my variance, I'm just going to square that number. I'm going to take 5197 and I'm going to square it. And wow, it's a huge number there, isn't it? So 27. Why is my pen? Sometimes my pen stops working. Hold on, guys. Let me see if I can get it working again. Okay, So now that I have that, let's see what these things sort of mean. Okay. The one thing that's really important is going to be our standard deviation. Okay. What we mean by the standard deviation is, on average, if we found the average of the salaries, there's going to be a group of them that are going to be about $5,200, because this is close to $5,200. You're going to have a certain group that are going to be plus or minus 5,200 from the average of, where was it? Right here, 59,300. There's going to be a certain group that's going to be about $5,200 plus or minus from there. And then there's going to be another group that's going to be this number times 2. And there'll be another group, that number times 3, that'll either be plus or minus from that average, okay? The standard deviation, a lot of times, guys, is what we refer to as the spread, okay? So same thing in the problem that we did over here. We're talking about the age, right? We're referring to the ages here. So this is about, I don't know, 3.2 years, right? If I was thinking about it in terms of a tenth. So the average age here was 21.3, and then there's going to be a group that's going to be about 3.2 plus or minus from that 21.3, okay? That's going to be my spread, okay? So I'm going to kind of skip over this other part right here and go to what we call the empirical rule, because the empirical rule is going to help me understand what standard deviation means, okay? So the empirical rule, or the 60, 95, 99.7 rule, says for data with a symmetric or bell-shaped distribution, right, all the information is in here, it's going to say about 68% of the data lies within one standard deviation of the mean. So here's my mean. I'm going to have 34% of my numbers here and 34% of my numbers here. That gives me a total of 68. Okay. 95% of my data is going to fall within two standard deviations. So this piece here and this piece here, I'll have 90% of all my numbers in as long as I'm about 2 deviations away. And then we're going to have 99.7 3 deviations away, okay? So again, what does a deviation mean? It means I'm going to take my mu, and then I'm going to subtract my sorry, didn't write it correctly. Either my population standard deviation or my sample deviation. And I'm not necessarily going to just subtract it. I can add it or subtract it, okay? Let me see if I can explain that a little bit better in this problem here. And it says, in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.3. Okay, so I'm going to just stop right there. Sample mean height. That's telling me that my X bar is 64. Oops. Oh, come on. Let me get this pen going again. Sorry, guys. Okay, 64.3 inches. There we go. Okay, and let me make sure this is still going. Yes, we're good. Okay, with a sample standard deviation of 2.62. So my S is going to be 2.62. Okay, now it says estimate the percent of women whose heights are between 59.06 and 64.03. Okay, so the first thing I notice is that we're looking for heights. This is going to be, if I think about like my number line right here, this should be my X bar. Okay, and my X bar in this case is 64.03. They want to know the percent of women whose heights are between 59.06 and 64.3. Okay, so what I'm going to do, the first thing I notice is that this is my sort of my bigger number, right? Which is right here in the middle, my mean, I'm sorry. So what I want to do is I want to figure out how far is 59.06 from 64.3. And what I mean by far, I want to know how many deviations is it away. So the way I'm going to do that, let me turn this guy back on. Let me clear that out. I'm going to take 64.3 and I'm going to subtract 2.62. Okay, that's going to give me 61.68. That's just telling me that this number right here, 61.68. Okay, let's do it again. Let's subtract another 2.62. Okay. There's my 59.06. Okay, so now that because I'm looking for the percent of women, what I'm going to do is I'm going to take this percent and add them together. So 34 plus 13.5. So let me grab my calculator again. 34 plus 13.5 is 47.5. Okay, 47.5%. And that's all it is I'm looking for, all right? Okay, now there's a second part to the question. And the second part says, if the study consisted of a total of 1,450 women, how many of the women would you expect to be between 59.06 and 64.03? Okay, so remember what we have. We have a total of 1,450, and we're going to find 47.5% of that. So 0.475 as a decimal. So let me grab my calculator again. 1,450 times 0.475 equals. So I would say about, I'm going to write, because it's asking me how many women. I can't have 0.75 of women. So here I'm going to say about 689 women would be in this group. Okay. So that's a little bit about the empirical rule. Okay, I'm going to do another example. Let me pull it up for you guys. Okay, so here's the next problem, and it says, apply the 68, 95, 99.7 rule to answer the question. It says, the systolic blood pressure of a group of 18-year-old women is normally distributed with a mean of 120 millimeters per, I forget what the little symbol is here, and their standard deviation of 12. Okay, so the first question says, what percentage of 18-year-old women in this group have a systolic blood pressure between 96 and 120? Okay, so we know that the mean here is going to be 120. So that number is going to be right here in the middle. There's my 120. Okay, so let me see. My X bar is 120, okay, and my standard deviation is 12, okay. So first thing I'm going to do, I want to figure out how many deviations away is 96 from my 120. My 120 is my upper limit. It's the bigger number that I have, okay. So let me grab my calculator again, and let's take 120, and let's take away 12, and that's given me 108. So that's going to be my number right here. Okay. And if I take away 12 again, that's given me 96. Okay. So again, I'm going to take 34 plus 13.5. It's given me 47.5%, right? And the question says, what percentage of 18-year-old women have a systolic blood pressure between 96 and 120? 47.5%, okay? All right, let's see if we can do the next one. It says at one college, GPAs are normally distributed with a mean of 3, okay? So here's my 3, and a standard deviation, so my X bar is equal to 3, and my standard deviation is 0.5. What percent of students at the college have a GPA between 2.5 and 3.5. Okay, so notice my upper limit is 3.5. That means that now I have to add. So if I were to take 3 and I were to add 0.05, I would come up with, 3.5. That's going to be my number right here. Okay, and if I take 3 and I minus 0.5, I come up with 2.5. That'll be my number right there. And again, the question says, what percentage of students have a GPA between 2.5 and 3.5? Well, everybody in this range. Well, 34 and 34 is now 68%. Okay. All right. So the next part is something called Chebychev's theorem. Okay, and it says any portion of any data set lying within k standard deviations, k is going to be bigger than 1, is going to be given by this formula right here. Okay. And we have a couple pieces of information here. It says when k equals 2, when we do our calculations, 1 minus 1 over 2 squared is the same thing as 1 minus 1 over 4, or 3/4, and 3/4 is the same thing as 75%. Okay. When k equals 3, we're going to do 1 minus 1/3 squared, which is 1 minus 1/9, which is the same thing as 8/9, or 88.9%. Now, guys, the time that I can use Chebychev's theorem is, so the empirical rule applies only to those that are bell-shaped and symmetric. This one applies to all distributions. So Chebychev's theorem always going to work. Okay. All right. So let's let's take a look here, and a couple of problems. We'll come back to the Alaska problem in a minute. Let's do this first one here. It says you're conducting a survey on the number of pets per household in your region. From a sample with n equals 40, the mean number of pets per household is 2 pets, and the standard deviation is 1 pet. Okay, so my mean, my x bar, is going to be 2, and my s is going to be 1. Okay, using Chebychev's theorem, determine at least how many of the households have between 0 and 4. Okay. So I want you to think about that again. If I take my number 2 and I subtract 1 and then I subtract 1 again, I get 0. And if I take my number 2 and I add 1 and I add 1 again, I get 4. So this here is telling me how many times that I have to subtract or add my standard deviation. I had to do it 1, 2, 1, 2. I had to do it twice. All that's telling me here is that my number k is equal to 2. So the formula says we're going to take 1 minus 1 over k squared. They did that calculation for us right here, and we came up with 75%. Okay, so now I have the number 75%. Remember, as a decimal, 75% is 0.75. The question is asking me, how many of the households have between 0 and 4 pets? 75% of them do, but it's asking me for a number. Well, how many households do we have? That's going to be my n. So I'm going to take 75% of 40, and that's going to give me 30. So 30 households have between 0 and 4 pets. Okay. All right. Let's do the same thing for the next one here. It says, using Chebychev's theorem, Old Faithful is a famous geyser at Yellowstone National Park. From a sample with n equals 100, the mean interval between Old Faithful's eruptions is 101.56 minutes. Okay, so let's write that down. X bar is going to be 101.56. Okay, standard deviation is going to be 42.69. We're trying to figure out at least how many of the intervals lasted between 16.8 and 186.94. Okay, so just like we did before, I'm going to take my calculator and I'm going to say, okay, let me turn it back on, let me clear it. What's 101 22.56 minus 42.69. Okay, I subtracted it once. It still didn't get me to my lower number, so I'm going to subtract it again. There we go. So if I subtracted it twice, so if I took my x and I subtracted 2 standard deviations, we're coming up with 16.18. Tell you what, guys, if we add our standard deviation twice, we should come up with this number. Let's verify, okay? So let's take 101.56. Now let's add 42.69. And we're going to add it again. And I'm coming up with, there it is, the 186.94. How many times did I have to do this? Twice. So again, it's just telling me that my k is equal to 2, right? So remember, we did this in the problem before. When k equals 2, we have 75%. The question, though, is saying how many intervals lasted between 16.8 and 186.94, 75% of them. 75% of, which means to multiply, how many am I looking at? 100. Well, 75% of 100 is just 75. Okay? Okay, so let's come back and do the Alaska problem here. And it says, the age distribution for Alaska is shown in the histogram. Apply Chebychev's theorem to the data using k equals 2. What could we conclude? Okay, so remember, in this case, my population is 35.3. My standard deviation is 21.1. Okay, so it's telling me that k is going to be equal to 2. So all I'm going to do is I'm going to add 21.1 to my mean twice, and I'm going to subtract it twice, okay? So let's add it twice first. So let's do this. Let's clear it out. Let's take 35.3, and we're going to add 21.1, and we're going to add another 21.1, and I'm coming up with 77.5. So when I do mu plus 2 standard deviations, we came up with 77.5. Okay. Now let's subtract it. So let's go 35.3 minus 21.1 minus another 21.1. And if you notice, I'm coming up with a negative number. So you can't have a negative age, right? So we're just going to say 0. Okay. So since we added this and subtracted this twice, right, we did this k equals 2. Remember when k equals 2? So we would say that 75% of Alaskans are between 0 and 77.5 years of age, or years old. Okay? And that's, in essence, what it's telling me.